Welcome to another lecture on complex numbers. Okay, so today we're going to look at multiplication and division in polar form. Okay, so given complex numbers in polar form, we're going to look at how do we divide them. Okay, so objectives here is multiplication in polar form and division in polar form. Okay, so with these two, we're going to understand why do we use polar form. Okay, so there is a certain reason why we change complex number from their standard form to this one polar form. Okay, so we're going to see that in this video. So please make sure you subscribe and you don't miss the next video where we're going to look at the important parts of complex numbers. Okay, so this is it. Let's get into it. The first thing we're going to talk about is multiplication of complex numbers in polar form. Okay, so before we go in, let's understand what is polar form. Okay, so polar form is when you are given a complex number like a plus bi, you are going to change it to become a form which is r cos theta plus I sin theta. Okay, so this is what we call a polar form. Okay, so this R is the modulus, and this theta will be the argument of that complex number. Okay, so in this case, let's say it's this complex number. Okay, so now let's take a look at how do we multiply two complex numbers when they are in polar form. Okay, so let's say we have our complex number. The first one, let's say it's given by z1 is equals to r1 cos theta 1 I plus I sine theta 1. Okay, so this is our first complex number. And let's say we have another complex number which is z2. Z2 is equals to r2 cos theta 2 plus I sine theta 2. Okay, so these are our complex numbers. Okay, so let's say you are being asked to find z1 and z2. Okay, this is what we call we are multiplying these two, this one and this one. Okay, so what you do is you just take the modulus and multiply them, so it becomes r1 times r2. Okay, then after that you have to take cos, then you are going to say theta 1 plus theta 2, then here is going to become plus I sine theta 2, theta 1 plus theta 2. Okay, so this is it. Okay, so the rule on multiplication is the first thing is you just have to multiply the modulus. Then the second rule is you just have to add the arguments. Okay, so as simple as that, you have successfully multiplied these two. Okay, so then if you ask to change them again back to this standard form, you can simply use your calculator to write to solve this and this. Okay, so this is it on multiplication. You just have to remember these two rules. The first rule is to multiply the modulus. You just have to multiply the modulus of this with the modulus of this. Then you just have to add these two arguments. Okay, so as easy as that, you have multiplied this one. Okay, so now you can see that this multiplication is easier than multiplying them in this standard form. This is the first reason why we use polar form. It is easy to multiply, it is easy to deal with it like this. Okay, so this is it. Now let's go and take a look at division. To divide two complex numbers, let's say we are given two complex numbers. Z1 is equals to r cos theta 1 plus I sine theta 1. Okay, let's say our r is 1, r1. Okay, now we have another complex number which is z2, which is equals to r2 cos theta 2 plus I sine theta 2. Okay, so now we are being asked to divide. Let's say we are being asked to say z1 over z2. Okay, so let's see how do we do it. Okay, so the first thing is like in multiplication, in this case, we're going just to divide the modulus. Okay, so in this case, we have r1 and r2. Okay, so we're going to say r1 over r2. This is the first step. Okay, then the second step is we're going to say, let me shorten this to become CIS. Okay, then our argument, what we're going to do with our argument is we're going to say theta 1 minus theta 2. Okay, so this is how we solve it. Okay, so the rules are simple. The first thing is we just have to divide the modulus, and the second thing is we just have to subtract the argument. Okay, so now this gives us a full form of like this, which is r1 over r2, then cos θ1 minus θ2 plus I sine θ1 minus θ2. Okay, so this one becomes our solution. Okay, so now our duty is just to simplify this, and we have successfully found our z1 over z2. Okay, so now you can see the reason why we choose to use in polar form. Okay, so let's write our steps of here. Okay, so the steps in this case is, the first thing is we just have to divide the modulus. Okay, so after dividing the modulus, the next thing is you just have to subtract the argument. Okay, so this is the simple step we have to follow when dividing complex numbers in polar form. Okay, now make sure the thing you are being able to make sure you're able to change a complex number in this form to polar form, and after converting it, you can just simply divide it. Okay, the next thing you have to learn how to change a complex number from this form back to this form. Okay, you just use your calculator and find the numbers. Okay, so it's very easy. Now let's take a look at examples. Okay, so before we bring our examples, let's first understand something. If a complex number is being said is r cos theta plus I sin theta, okay, there is a simple way we can write this. Okay, so as easy as that, you can just say a complex number is r cos, just represented by c, then represent I, then say s representing sine, then include theta. Okay, so you can write it in this way. I don't know if it is acceptable in your exams, but you can just use this short way to calculate, and when you're giving the final answer, you use this one. Okay, so please understand this one. You can just represent it with the first letters here, and include your angle. Okay, so as easy as this. Okay, so this is what we're going to do. The first example is saying that multiply z1, which is 2 cis 30 degrees, and z2 is 3 cis 45 degrees. Okay, so this is it. Now we just have to multiply this. This means that we are going to find z1 multiplied by z2. Okay, so this is z1 z2. Okay, so what we're going to do, as our law suggests, that we just have to multiply the moduluses. Okay, so this means that we're going to say 2 times 3. Okay, after that we just have let's write our cis. Then the next thing, we're just going to add the arguments. Okay, in this case we have 30 degrees, and we are being added with the other one, which is 45 degrees. Okay, so now this means that we are going to get our answer as here is 6 like this, and 30 plus 45 is going to become 75 degrees. Okay, so this becomes our answer. Okay, so let's express this back in this way, which is a standard polar form. This means that we are going to get our answer as 6 cos 75 degrees plus I sine 75 degrees. Okay, so in this case we have successfully added these two. Okay, we have successfully multiplied these two. Okay, so this is the easy way. This is the example. Just multiply the modulus and then add the arguments. Okay, let's get into the second example. The second example is saying divide z1, which is 4 cis 120, by which the other z2, which is 2 cis 30. Okay, so now what we're going to find is, in this case, is z1 over z2. Now we're going to take a look at this. The first rule of division is we just have to divide these roots. Okay, so in this case we're going to say 4 over 2 like this. Then we're going to write our cis here. Then 120, we're going to say 120 degrees minus 30. Okay, so this is it. So what we're going to do is with the rules, divide and subtract. This is our law on division. Okay, so this means that we're going to get our answer as 2 cis 120 minus 30, we're going to get 90 here. Okay, so this means that our answer is going to become 2 cos 90 plus I sine 90. Okay, so as easy as this is our answer. Okay, so now after this, sometimes you may be asked to change this back to this form A plus BI, which is the standard form. Okay, so changing this back, you just have to take this part and use your calculator to have your answer. Okay, then this becomes A. Then you take this 6 and this part, this answer becomes your B. Okay, with a 6 here, remember, with this 6, then this answer becomes your B. Then you have your I here, so this is your answer. Okay, so now in this case, you're going to take this 2 and this 90, you're going to get an answer, and I assume it's 0 here. Then next here, you're going to get our 2 here, put your 2 here, then you take this and become the second answer. I assume it's 1 here. Okay. And in this case, you can get your answers cos 75 and sin 75, then multiply by 6. Okay. So this is how we multiply and divide complex numbers. Okay. As easy as that. So this is, in this case, I think you have understood why we use polar form. Okay. So it is easy in multiplication and division. Okay. Then the next step you're going to look at is you're going to find the powers of these complex numbers. Let's say z1 to the power 4. Okay. You can easily find it in polar form, and you can it is very hard to use this way. Okay, so this is the other reason. And the other thing, you can find the cube root of a complex number. Let's say it's being asked to find the cube root of z1. Okay, it is very easy to use in polar form. Okay, so make sure you've understood how to change in polar form, and make sure you've understood how to multiply and divide. Okay, so see you in the next lecture, and make sure you subscribe so that you won't miss it. Thank you.